Hello and welcome to our Java project. Lecturer Nissim Barami, developers Rea Bar and Eileen Hirsch. In our project, we chose to work with two algorithms to solve the maze. The first one is the best first search. As you can see here, it's pseudocode. The best first search is a search algorithm which explores a graph by expanding the most promising node chosen according to a specified rule. And the second one is the A-star algorithm, which is an example of best first search. And the A-star algorithm is widely used in pathfinding and graph traversal, the process of plotting an efficiently traversable path between multiple points called nodes, noted for its performance and accuracy. And also we chose two different methods and two different heuristics to use with the A-star. The first one is Manhattan distance, and the second one is the air distance. Now let's see how the program actually works. So here I open two clients and the server. First we need to power on the server, so let's power. Here is the number of clients that can connect to the server simultaneously. Let's define 6 and the port number. Okay, and as you can see the server now is on. Let's fire up the first client. Okay, we need to set the properties first. So we set the properties, number of threads, and the algorithms that we want to generate and solve the maze with, and which UI we prefer, and the server IP and port as we defined. Okay, now let's generate. Okay, now let's display here. So as you can see, we got the generated maze with our character and everything. And here we are stuck. We can't move right, left, backward, or forward. So we can move up or down. Let's try. We will move the up, then we can move. Yes. And okay, now if we want to solve the maze and get hints how to get to the end of the maze, we need the server for that. So the client connects to the server using TCP connection, and here we will press the solve maze, and we see that the server notifies us that he got a new connection. As you can see here, this is the address of the client that we just pressed the solve maze button, and we got back the solution from the server. And here we can see the number of solutions we are caching. Currently we only have one solution for this current maze. So if we will press solve again, we will see that this number won't increase. Let's see, new connection, and as you can see the number didn't increase. And here we are writing the maze and the solution, how it saves in the database actually. And I will get into that very soon. So let's go back. Now let's open a new client. Generate. Oh, first we set the properties, of course. Okay, so let me show you how the solve actually works. Press the solve, then we got this connection again. Okay, now let's use the hints. Okay, the solution that came from the server tells us to move right, backward, up, and left. And here we got to the end of the maze. As you can see, there is an image that pops off. The character image changes. Okay. Now that we finished solving the maze, let me show you how we can exit correctly and without any thread running. So first option is to press the exit button, a successful exit. And another option is to press the X button on the keyboard, successful exit. As you can see, there is no thread running in the client side. And now let me show you how we close the server. So we press the stop, a successful exit, and no thread is running as it should be. Now let me show you how we are saving the solutions, and we are caching them actually. So we use the Hibernate. We are saving the solutions to an external database using MySQL. And so here we got the code to saving and writing, to reading and writing the maze and solutions from the database to an hash map called solutions. So this is the write method and the read method, and here we got the connector to connect between the Eclipse and MySQL. And here is the SQL with our database. It's called Maze3D. It got 3 columns, the ID and Maze column and the solution column. Now let me show you. Now we will have 2 solutions, I believe, that we saved now to the database. Let's see. And here we go. As you can see, ID is 1 and 2. The objects are blob, which are binary big files to save the maze in the solution. And that's it. Okay, now I will show you our client side. So our client side architecture is based on MVP, the model, view, and presenter. And the presenter is an observer, and the view and the model are observables. The presenter knows the view and the model, but the view and the model doesn't know each other. So we got a full separation between the view and the model, which lets us a lot of flexibility and to change each part of the MVP anytime we want. And now let me show you it on our project. So here is the MVP architecture on our project actually. As you can see, the presenter, which also has an interface of commands, the model interface and the class itself, the client model, and also the view, the basic window, maze display, and the character. Each are separated. It's very generic. We can replace it easily. It's not difficult at all. And we also got the CLI, but I prefer to show you the GUI at the moment. I will start from showing you the view, and next we will move to the other parts of the MVP. So in the view we got an interface named view, which defines the methods that each future developer that will work on a project must implement. And as you can see, show maze size, print maze, and other things. And then we got the myView CLI, which is a standard command line that can interact with the user using command lines, strings. And we got the GUI, which is more complex. Of course, we got different classes, we got abstract classes, we got another interface for the character, and the GUI is more complex because we want future developers to be able to easily and change parts of the graphic user interface, such as the character. So we got the character interface, which defines the methods that the next developer should use, but he can change them, of course, however he wants. Like my character 2D, our character is actually Winnie the Pooh, and next developer can change it to whatever he wants. He can draw, he can replace the picture. Flexible, easy. We also have the maze window, which is the default window of the game, of the maze. It also can be replaced very easily. All you got to do is to extend basic window and implement view, and you can change the whole graphic user interface. Now let me show you the presenter. And so the presenter implements observer, as I said before. The observer class obliges us to implement the update method, which has 2 arguments. The first is observable. So in our project it's the view or the model, and the second one is a generic object. Also, the presenter holds a hash map of all the commands that he can get from the view, and then move it to the model and activate them in the model. And as you can see here, these are all the commands that we have in our project. We also got a different package for all the commands. Each command has its own class, and we also got an interface for the commands, and then an abstract class. And each command has its own class, of course. And in the specific command class, we activate the specific method in the model. The main purpose of the presenter it's just to connect between the model and the view. So we got a separation between the different parts. So the project will be very generic and again very flexible. And now let's move to the model. So the model also have an interface like the view. The interface here is named model, and we got all the methods that we force the future developers to implement. if they want to change anything. And as you can see here, different methods like move up, move down, shut down, show size in file, etc., etc. Now let me show you the client model. So the client model implements the model and extends observable. And I believe this is the heart of the project and especially of the client side. And here you got the implementation of all the different methods, such as to move, to show things, to save things, and also to generate. Now let me show you the generate method, for example. So the generate, you can generate by two algorithms, as I said before, the DFS or the random one. Here, to make it more reliable and faster, we open a new thread, use the future. We open a new thread, we generate the maze, and then we return the maze. So at the time the thread generates the new maze, the client side isn't stuck, and it keeps continuing, it keeps moving and listening to the client. So this is basically, I think, the most important part, the implementation of the method. And now let's move to the server. Now I will show you the server-side code. So the server also is based on MVP, which means we got the model, the view, and the presenter. And as well as the client side, the view here also has an interface. And then we got the GUI and the CLI, which implements that interface. And the presenter and the model are the same like in the client side, but the only difference here that the model is only solving the maze that the client is sending us through a TCP connection. And let me show you the algorithm. So here we are solving the maze. First we iterate through the hash map of solutions to see if we already solved that specific maze, if we cached the solution in our external database using MySQL and Hibernate. And then if we didn't, then we solve the maze. We are first opening a thread using the future, and then we are going through the algorithm which we chose, and then we solve the maze using the different algorithms we have, and we return the solution. Then we write the maze and the solution to the hash map, as you can see here, and then we also save it to the database, the Hibernate, and then we close the connection with the client. So as I said, the server is working over a TCP. We are committing a communication with the client in the network package. As you can see here, we got the myTCP IP server. And once again, we open a thread for the communication. The server is listening till the person who ran the server asks to kill the server. And once the client is connecting, we move to the client handler. And here we are opening once again a new thread. We got a new model for that specific client, and we pass the arguments that the model needs to solve the maze, which is the maze and the algorithm that the client chose. And that's mainly it. Thank you very much for listening.